In zinc phosphate cement, we have to describe the composition, chemistry, and manipulation properties of zinc phosphate cement is the oldest type of dental cement used in dentistry, and it is still used as a standard against which newer cement bases are compared because of its good properties. The application of zinc phosphate cement, the main uses is the cementation of cast restoration and cementation of orthodontic brackets. It is used as a cement base under metallic restoration because of its good insulating properties. Also, it is called high strength base because it has a high strength compared to the other types of cement. Also, it is used as a temporary filling material. The zinc phosphate cement comes in the form of powder and liquid. Basic powder for sure and acidic liquid to be hand mixed on a thick glass slab and stainless steel spatula. The main ingredient of the zinc phosphate powder is zinc oxide. About 90% of the component is zinc oxide. Together with magnesium oxide aid in the calcination of the powder during manufacturing. Other oxides are added such as silicon oxide used as a filler to give strength, bismuth oxide to smooth the mix with other oxides. The calcination process means combining all the ingredients together by the manufacturer for sure, heating them to a high temperature till all the ingredients are fused together, then grind them to the fine powder. The particle powder is ground according to the purpose of use. For example, for when we use it as a cement base, the powder must be larger than when it is used as a luting agent. The calcination process is important because it reduces the reactivity of the powder to the liquid. The zinc oxide is reacted with the phosphoric acid very rapid, so we don't have enough time for the working time. So the manufacturer trying to reduce the reactivity between the powder and the liquid by the calcination process to allow longer working time. Also, the calcination process helps that each particle of the powder have the same composition, so this will adjust the reaction. The liquid is mainly phosphoric acid. The phosphoric acid is about a third of the liquid. It's composed almost of 38% of the liquid. It's a free phosphoric acid that reacts with the zinc oxide powder. Also, the liquid composed of aluminum and zinc phosphate already reacted. So this partially neutralization of the phosphoric acid reduce also the reactivity of the reaction between the powder and the liquid. We also have aluminum and zinc ions which acting as a buffering agent. The water, which is an essential component of the liquid, is about 36%. It acts as ionizing agent when the powder comes in contact with the liquid. to begin the reaction. The reaction of zinc phosphate cements begins with the acidic liquid contacting the basic zinc oxide powder where ionization occurs and release of zinc ions from the surface of each particles occurs, and in the presence of alumina there is completing the reaction forming the zinc aluminophosphate cement matrix, and this is the reaction product forming the matrix of the cement. Here we have to bear in mind that only the surface of each powder reacts the with the acid. Not all the particles consumed in the reaction. There must be a core of the zinc oxide particles remaining inside the matrix. Why? Because this gives strength of this set cement, as the formed matrix is weaker than the original zinc oxide powder. So in conclusion of the zinc phosphate cement setting reaction occurs between zinc oxide powder, phosphoric acid, and water in the presence of alumina ions, which is already present in the liquid, results in zinc aluminophosphate, which is amorphous gel matrix. Embedded in it the unreacted zinc oxide powder particle. And this is scanning electron microscopic photo of the set cement. This is the matrix of the cement, which is zinc aluminophosphate, and this is the unreacted zinc oxide particles, because only the surface of the particles is reacted with the phosphoric acid. The character of this reaction is rapid and exothermic. So the exothermic heat of reaction accelerates the setting time of this type of cement, which doesn't give enough time for the working time. So we have to minimize this heat evolved during the reaction to extend the working time. Extension of the working time can be done by the operator during the mixing procedure of this type of cement. The mixing procedure done using a thick, cool and dry glass slab and stainless steel spatula. First of all, we dispense the powder at one side of the glass slab and dividing them into small increments, 8 increments or more. Then dispense the liquid on the other side of the glass slab. We dispense the liquid at last to prevent water evaporization from the dispensed portion of the liquid by the atmospheric heat. Then we begin mixing with taking a very small increment of this by taking a very small increment and added it to all the liquid, mixing it on a very large area of the glass slab in rotatory movement in one direction. Why we take a very small portion and mix them with all the liquid? This is to need to partially neutralize the liquid. When all these small part of the powder react with the all portions of the liquid, this will lessen the reaction of the liquid to the next portion of the powder, and will extend the working time. Also, there is a minimal amount of heat evolved during this part of the reaction, which will be absorbed by the thick cool slab. Over the thick cool slab, we mix a small increment over a large area of the slab, and then take another increment and mix it over the large area of the slab, and so on till we reach the proper consistency suitable for the use of this type of cement. We reach the thin consistency when we want to use it as a luting agent. We know that we reach the proper consistency when we draw the cement when we left the spatula with the cement, and the cement follows the spatula for about 1 inch. If we want to use it as a cement base, we have to reach a putty-like consistency. So we have to add more powder as recommended by the manufacturer for this type of use till we reach a thick consistency, which is a putty-like mix. As a general rule, we have to use the maximum amount of powder, which gives the proper consistency. The mixing time for each increment must be 15 seconds, which will give us a total of working time from about 90 to 120 seconds, which about 1.5 or 2 minutes. And this type of which is a long working time, adequate for manipulation and inserting the cement inside the tooth cavity, with a total of setting time of about 9 or 10 minutes. The working time of zinc phosphate cement will be controlled by controlling the rate of the setting reaction between the powder and the liquid, and this is done either by the manufacturer or the operator or both. The manufacturer controls the setting reaction by controlling the degree of calcination. The higher the temperature of calcination, the lower will be the reaction, and the longer will be the setting time. The particle size of the powder. The smaller the particle size will result in increase the rate of the reaction and reduction of the working time. The water content of the liquid. The increase of the water content will increase the ionization and will increase or accelerate the setting reaction, reducing the setting time. The composition of the liquid related to the water content and the free alumina and zinc ions in the liquid will control the rate of the reaction. By the operator, the working time can be controlled by the powder-liquid ratio. So the increase in the liquid will accelerate the setting reaction and accelerate the working and reduce the setting time. The rate of the powder incorporation, so we have to use small increment by small increment to prolong the working time. And the time and the manner of the spatulation. The manner of the spatulation must be increment by increment to reduce the setting, to reduce the rate of the reaction. And also it must be done over a large area of the glass slab. The temperature of the mixing slab, the cooler the glass slab will extend the setting will extend the working time because it will absorb the heat evolved from the reaction. So by the operator, all these method can control the working time can be increased by controlling these factors, but the best one is the temperature of the mixing slab because it will not change the physical and mechanical properties of the cement, because any change in the powder liquid ratio will change the final properties of the set cement. Also, the amount of water of the mix can change the rate of setting and the working time. The viscosity of the zinc phosphate cement, it has good low initial viscosity, and the low initial viscosity is needed to give thin film thickness, and this will give good flow and good wetting of the cement and the restoration by the cement. Also at the margin it will be very thin and it lessen the degree of solubility of the cement in the oral fluid. So one of the best properties of this cement is low initial. The viscosity of zinc phosphate cement increased by increase in time and temperature. So it must be used immediately after mixing, not to leave them for a while on the glass slab. This type of cement has a film thickness of 25 micron, which is recommended by the ADA. And this film thickness is affected by many factors, such as the particle size of the powder. Sure, the smaller the particle size, the thinner will be the film. The powder liquid ratio, the increase in the powder will increase the film thickness, the initial viscosity, and the forces applied during cementation. We know that during cementation of the crown, we have to put a slight pressure with the dense finger for the cement to spread over the tooth and the crown. If this force is increased, the film thickness will be thin, and if the force of cementation reduced, there will be not enough wetting of the cement, so it will not spread good over the tooth and the restoration, and the film thickness will increase, which is accelerate the failure of the restoration during service. The restoration bond with the cement by mechanical retention. So the cement bond the tooth to the restoration to the tooth by mechanical interlocking. Mechanical interlocking through the irregularities of the tooth structure and the restoration. The irregularities come from the preparing instruments or burrs used to prepare the tooth. It leaves small irregularities on the tooth structure, which is transferred to the restoration during impression and casting. Also, there will be roughness on the inner surface of the restoration, which is the mechanism of bonding between it and the cement. The cement is soluble inside the oral fluid, and the solubility and disintegration of this cement occurs first at the margins of the restoration. Here is the tooth, and this is the restoration, and this is the cement layer between them. If the cement dissolved from the margin of the restoration, this will lead to micro leakage, and this micro leakage will lead to deposition of saliva and food debris and make a recurrent caries happens, and this is a failure of the restoration. So the solubility increase with the decrease of the powder liquid ratio. So we have to mix the cement with a proper powder liquid ratio to prevent early solubility in the oral cavity. The zinc phosphate cement has high mechanical properties. It has high compressive strength and have high modulus of elasticity. But as all type of cement, it has a low tensile strength. That's why it is brittle. The strength of the cement is affected by the powder liquid ratio. Again, the increase in the powder liquid ratio increases the compressive strength of the cement. And this type of cement has a good property, which is reaches its 50% of the final compressive strength after setting or after 10 minutes of beginning of the mix, which is also a good property of zinc phosphate cement. The disadvantage of the cement is considered as its acidity. The zinc phosphate cement at the bottle or the cement liquid phosphoric acid, it's about 1. pH is about 1. When mixing, start of the mix, it will increase to 2, and then it will increase by time. The pH will increase till it reaches to neutrality after about 1 to 2 days. So the zinc phosphate cement has free acids for at least 1 day. So this free acid can pass through the dentinal tubules, causing a chemical irritation to the pulp. So a contraindication of this type of cement is its use over a thin dentine. So this cement must not be used when the remaining dentine is thin. If we have a thin remaining dentine between the tooth cavity and the dental pulp, we have to use a liner before we put the zinc phosphate cement. And these are 3 types of cavity depths. There is very deep cavity. So the remaining dentine is less than half millimeter. We have to put a liner before we put the cement. And this is a very shallow cavity. So we have a very large amount of dentine between the tooth of the cavity and the dental pulp. So we can use a very thin layer of the cement base or put a liner alone because we have enough dentine. And this is the normal depth cavity which have a dentine layer about 2 millimeters. We can put only a cement base over the cavity. And the free here in this type of cavity, if the free acid penetrates through the dentinal tubule, the can be diluted by the water in the dentine, or if it reaches the pulp, it will reach it very weak, cannot cause an irritation, and the immune system of the pulp tissues can overcome this acidity. So the advantage of zinc phosphate cement is it's easily manipulated. It has low initial viscosity and low film thickness. It is a thermal insulator, so it can insulate the pulp from electrical, thermal, and mechanical stimuli. It has a high compressive strength and high modulus of elasticity, so it cannot be fractured under the forces of mastication if properly inserted in the tooth cavity. It has longevity in the oral cavity, can last for years without any problem. While the disadvantage summarized in the pulp irritation and post-operative sensitivity. The main disadvantage of zinc phosphate cement is pulp irritation. Lack of adhesiveness to the tooth structure. It cannot bond chemically to the tooth structure. It bonds by mechanical means. Lack of antibacterial effect. It is brittle, of low tensile strength. And this is the end with zinc phosphate cement. And now we can answer these questions after we study carefully this type. The effect of reduced powder-liquid ratio on the setting time, solubility, strength, and pH of the zinc phosphate.